Hello everyone. Today we are going to study the basic concept of hydrocarbon. We are also going to study about alkane, alkene and alkyne and nomenclature of the hydrocarbon. Basic concept we are going to develop today. Let us see first some examples, then we will discuss about the different types of hydrocarbon. Let us observe this all the compound. Here, one carbon is covalently bonded with four other carbons. Similarly, in this carbon is bonded with this carbon, and these all other carbons are bonded. All the carbons are bonded with hydrogen, and this all is the covalent bond. When we observe all this compound, we find that the all the compounds contain hydrogen and carbon only. These compounds are known as hydrocarbon. So we define the hydrocarbon like this: the compound containing hydrogen and carbon only, that compound is called hydrocarbon. I hope you understood this definition of the hydrocarbon. The hydrocarbon is divided into two groups: saturated hydrocarbon and unsaturated hydrocarbon. Let us see, observe all these compound. We see that in this compound there is only presence of single covalent bond. In this compound also only single covalent bond is present. But when we observe this compound, there is a one double covalent bond and rest single covalent bond. Here one double covalent bond and rest single covalent bond. In this compound, one triple covalent bond and rest single covalent bond. Then the hydrocarbon in which there is only presence of single covalent bond, that type of hydrocarbon is called saturated hydrocarbon. We can say this compound and this compound, it is these compounds are saturated hydrocarbon because they consist of only single covalent bond. But if any hydrocarbon, they consist of at least one double or at least one triple covalent bond, they are called unsaturated hydrocarbon. These all compounds, these they contains at least one double covalent bond or at least one triple covalent bond, then these all compounds are the example of unsaturated hydrocarbon. The saturated hydrocarbon, this is also known as alkane. Saturated hydrocarbon, this is also known as alkane, while unsaturated hydrocarbon, this is studied under two heading, uh, alkene and alkyne. Alkene and alkyne. Alkene contains at least one double covalent bond, yani this compound contains at least one double covalent bond, This compound also contains at least one double covalent bond. These two compounds are the example of alkene. While alkyne means those hydrocarbon that contain at least one triple covalent bond. We can see here this compound contains one triple covalent bond here. This compound also contains one triple covalent bond here. So these two compounds are the example of alkyne. I hope you understood the concept of alkane, alkene and alkyne. Once again, we are going to revise this. Hydrocarbon means the compound containing hydrogen and carbon only. Suppose this is one compound, here only carbon and hydrogen are there, no other elements are there in that compound. Then this type of compound where only carbon and hydrogen is there, that compound is called hydrocarbon. It is divided into two groups. Saturated hydrocarbon, it means they consist of only single covalent bond. Saturated hydrocarbon is also called alkane, while unsaturated hydrocarbon consists of at least one double or at least one triple covalent bond. Unsaturated hydrocarbon, it is divided into two groups, alkene and alkyne. Alkene, it is the hydrocarbon that consists of at least one double covalent bond, while alkyne means the hydrocarbon that consists of at least one triple covalent bond. They are called alkyne. The general formula of alkane is CnH2n plus 2. Similarly, the general formula for alkene is CnH2n, while the general formula for alkyne is CnH2n. What is this general formula? Let us understand. Suppose this, if we want to check any hydrocarbon, uh, which hydrocarbon it is, then by the help of this general formula we can check either it is alkane or it is alkene or it is alkyne. Let us see example. Suppose we have to check, suppose this is the structural formula, but if its molecular formula is written like this, there are two carbon, C2 and H how many? 1, 2, 3, 4, 5, 6. C2 H6 is written. C2 H6 is written, suppose, and if somebody asks you C2 H6, it is alkane, alkene or alkyne. If a structure is given, we can easily say, but if molecular formula is given, then how we will identify it is alkane, alkene or alkyne? We can identify by using this general formula. How we will use this? Let us see here. In this formula, we will put the number of carbon. This here is 2, so we put here 2, and if the hydrogen value comes here 6, then this compound is falling under the alkane. For example, in this formula we are putting C here 2, then here n value we are putting 2, C2, then let us see H value how much it is coming, into 2 plus 2, C2 H6. This is matching with this, so we can say this compound is alkane. Suppose if any unknown molecular formula is given to us, suppose like this. Suppose C5H10 is given. Now we have to identify this compound is alkane, alkene or alkyne. Then we have to check in this formula, all these formula. Let us keep here value of carbon here 5, so here value we are keeping 5. Let us see what happens here. C5 H 2 into 5 plus 2. C5 H 5 to the 10 and 2 12. Here H value is 10, but here H value is coming 12. So this compound is not alkane because this formula is not fitting to this molecule. Similarly, we will check this with this formula. Now here Cn is to n. So here C5 is here. So we are keeping the value of n5. Then N's value will be 2 into 5. C5 N's value is coming 10. Here we see that if we are keeping the value of n5, N's value is coming 10, and this N's 10 is matching with this, then we can say this compound belongs to this formula, so it is a alkene. I hope you are understanding how to use this general formula. Now, if difference between alkane, alkene or alkyne we have to remember, then we can remember like this. Alkene, this is a hydrocarbon, this consists of only single covalent bond. Alkene, alkane contains only single covalent bond. Alkene contains at least one double covalent bond. Alkyne contains at least one triple covalent bond. Similarly, the general formula of alkane is Cn plus 2. Its general formula is Cn. Its general formula is Cn, sorry, it is Cn minus 2. Please edit this. It is Cn minus 2, and this is Cn. This is Cn plus 2. I hope you understood this concept of alkane, alkene and alkyne and type of hydrocarbon. Now we are going to name how the name of this compound is done. What is the name of this compound? We are going to study the nomenclature of alkane, alkene and alkyne. How naming of the such type of compound is done, we are going to study. Let us see. There are two types of name. One is the trivial name, that is given on the basis of source from where that compound has come. Another is IUPAC name, that can be considered as scientific name also. IUPAC name we are going to study, scientific name. There is some rule first we need to understand before naming the hydrocarbon. Rule is that IUPAC name is equal to root word plus suffix. Root word plus suffix. And what is root word? Let us see. Root word is determined by number of carbon. Okay. For example, if the number of carbon in the hydrocarbon is 1, then root word will be meth. If the number of carbon is 2, the root word will be eth. If the number of carbon in that compound is 3, there will be root word prop. Number of carbon is 4, then there will be root word but. If the number of carbon is 5, there will be root word pent. If it is 6, then there will be root word hex. Similarly, this suffix is determined by the type of bond. For example, suppose this is like this, type of bond determines the suffix. Suppose if any compound has only single covalent bond, then suffix will be ane. If it has at least one double covalent bond, how many single covalent bond, it does not matter, but if at least one double covalent bond, then there will be suffix ene. Similarly, if there is at least one triple covalent bond, then the suffix will be yne. Please take a screenshot of this. I am going to rub this because I am using this rules while naming the different types of hydrocarbon. Please take a screenshot. We are going to use these rules to name the hydrocarbon. Let us see some example here. Suppose we have to name this compound. Then we have studied IUPAC name is equal to root word plus suffix. Then first we have to write root word for this. And for root word is determined by number of carbon. Here how many number of carbon? It is 1. Then if carbon is 1, then root word will be meth. We can see the previous thing on the board. There was, if carbon number is 1, the root word will be meth. And in root word we have to add the suffix. Suffix is determined by the type of bond. Then what is the type of bond over here? Only single covalent bond. Then what will be the suffix? If there is single covalent bond, then ANE. Thank you. ANE. Then its name becomes methane. This compound name becomes methane. Similarly, if another compound is given like this, then what will be the name of this compound? Please you try. We have to see the root word first, and root word is determined by number of carbon. There are 2 carbon here, then root word will be, if there is 2 carbon, root word will be ETS. And here now suffix will be determined by the type of bond. Type of bond here is single covalent bond, then root word plus ANE, that becomes ETH. ETHAN. Its name becomes ethane. Similarly, if there is 3 carbon, then propane, like this. If there is suppose this compound we have to name. I hope you are understanding. We have to name this compound. Then this is prop, because root word is prop for 3 carbon, and we have to add ANE for single covalent bond. Its name becomes propane. Okay, let us take some other example also. Now you also try by yourself. I am giving here some structural formula. Suppose we have to name this compound. Try. What will be the name for this? See here, how many carbon is here? 3. So root word will be prop. And only single covalent bond or double covalent bond is also there. Here is one double covalent bond. Now if at least one double covalent bond is there, then we have to add here ENE suffix. So its name becomes propene. Okay, I hope you are understanding this. Let us take another example. What is the name for this? You try. There are 2 carbons, so root word will be eth. And here at least one triple covalent bond is there. Then root word is added with YN, because if triple covalent bond is there, suffix will be YNE. So the name of this compound is ethyne. Okay, I hope you are understanding this. Let us take some complex form of this. Okay, another another also similar compound we are taking. Now you try to name this compound. See, here is also 4 carbon, so root word will be but, but, and here at least one double covalent bond, so root word is added with ene. The name becomes butene. And see this compound also, it has 4 carbons, so root word will be but, and at least one double covalent bond, then suffix will be ene. It becomes butane. These both compounds, when we observe nicely, these two compounds are not the same compound, because it has double bond at this first carbon, and here the double bond is at middle, second carbon. Then how can these two compounds be same? It is not the same compounds, but name is coming same, which is going to be create misconcept in our mind. Two different compound cannot have the same scientific name. So how its name is written? Try to understand. We have to indicate at which carbon double or triple covalent bond is present. We have to denote the number also. For example, here in first number carbon, if we are naming this carbon from this side, it is 1 2 1 2 3 4, it is coming. And if we are counting from here, at first number carbon double covalent bond is present. If we are counting from this side, 1 2 3 number carbon, it is coming covalent bond. Then from which side we are counting less number is coming, we have to put that number in front of the name. So from this side 1, and from this side it is coming 3. 1 2 3 it is coming. Here double covalent bond is here. From this side, if we are counting in this one number carbon, there is double covalent bond, so we have to use 1 before the name. We can use like this also, 1 butene, or like this also we can write but 1 dash ene. Double covalent bond is present at the first carbon. Similarly, please say what will be the name of this. From this side, if we count 1 2 number carbon, there is this bond. From this side we are counting 1 2, second number carbon, this double covalent bond is there. From both side number is coming 2, so its name will be 2 butene, or simply we can say but dash 2 ene. I hope you are understanding how to name the uh, hydrocarbon: alkane, alkene, and alkyne. Okay. If a structural formula is given, this is the structural formula, then we can write the name like this. Now we are going to understand, if name is given, then how to draw the structure. Okay. Suppose a question came in front of us: draw the structure of 2 uh, butane. Draw the structure of 2 butane. Then how to draw the structure? From where to start? Try to understand. First we have to observe the root word. The root word is but. Then if there is but, how many carbon will be there? Say, okay, thank you. 4 carbon will be there. Then 4 carbon we have to arrange by single covalent bond at first. Okay. Then here is YNE. YNE indicates there is triple covalent bond in this compound or molecule. Then one triple covalent bond we have to keep anywhere here. We have to observe this number. At 2 position, second position carbon, we have to keep the triple covalent bond. And from anywhere we can count, there is no restriction. 1 2. In this second carbon, we have to keep here triple covalent bond. Okay. Now we have to manage 4 bond around all the carbon. For example, this carbon has one bond here, one covalent bond here, and rest 3 is required for this, and we have to put here hydrogen to maintain its 4 bond. Now see this carbon. This carbon has one bond here and 3 bond here. Total 4 become. We do not require any hydrogen. Similarly, this carbon 3 bond this side and 1 bond this side. It has also become 4 bond. So it do not require any hydrogen. This carbon 1 bond is here present and 3 side it requires hydrogen, so that its 4 bond will be completed. Now this becomes the structure of 2-butene. I hope you are understanding. Suppose question came to us, draw the structure of propane. Simple it is. Then we have to see this root word first. Prop. How many carbon is present in if the root word is prop? Okay, 3 carbon. Then 3 carbon we have to arrange like this. Now we have to see this suffix ane. Ane represents only single covalent bond is there. So everywhere we are going to create only single covalent bond and put their hydrogen. Every carbon 4 bond we are going to complete. This carbon 1 2 3 4 bond became. This carbon also 1 2 3 4 bond became. 1 2 3 4 bond becomes. This becomes the structure of propane. Question came to you, draw the structure of ethane. Ethane. Then we have to see this root word eth. It is indicating 2 carbon. Then 2 carbon we have to arrange by single covalent bond. We have to see now suffix. Suffix is ane. It has only single covalent bond.